If you are watching this video for the first time, make sure you are subscribing to Anantha Lakshmi Academy. Once you click on the subscribe button, you will see a bell icon. If you click on that bell and click on all, you will get to know whenever I upload a video. This will send you a notification. Hello everybody, welcome back to Anantha Lakshmi Academy. As promised in the earlier video, today we are going to discuss the third chapter of 10th class mathematics, which is polynomials. What is it? Polynomials. Interesting word, right? So, before discussing what is a polynomial, how is it, how can we form a polynomial and all, let's take an example of a square. We are all familiar with the word square, right? Square is the one which has 4 equal sides. If I say the side of a square is x, then what would be the rest of the 3 sides? They will be x, x, x. Isn't it? Because in a square, all the sides are equal. Hence, if I ask you guys to figure out the area of a square. Area of a square with side x is side into side, which is nothing but x square. Alright? If I ask you guys to figure out the perimeter, then perimeter is equal to, what is the formula for perimeter? 4 into side, which is nothing but 4x. Now, the side is in x square and the perimeter is in 4x. Okay, so far whenever we are whenever we figure out the areas or perimeters, they used to be in numbers. But now they are in the form of x. And here it is a power which is 2. X power 2, which is known as x square, and this is 4 multiplied with x, 4x. So these terms which are in the form of x, this is an expression in x, are known as polynomials. This is a polynomial. X square is a polynomial, 4x is a polynomial. Alright, so this when you do not know the sides, or when you have equations or expressions in terms of x with rising powers or dropping powers of x, then they are said to be polynomials. Okay, let's come to the definition of a polynomial. How is it? Polynomial, what is a polynomial? Let's discuss in detail. Okay, a polynomial is an expression. What is it? An expression. There is a lot of difference between expression and equation. Equation is which has equal to in between. You will have LHS and RHS as well. Alright. But when it comes to expression, there will be only one entity, which is only, you do not have the other side of it. When it is an expression, you just have one single term. That is an expression. Alright. If you see this, x square is an expression. 4x is an expression. Likewise, polynomial is an expression in x. In what terms? In terms of x, which is, it is an expression in x, which is expressed as sum of finite number of terms of a into x power n. What do we got here? X square. X square is considered as x power n. A is nothing but here there is no nothing as a constant which is multiplied to x square. So we can consider it as 1. So in number of, it is expressed as sum of finite number of terms of x power terms of a into x power n for any real number a, and any whole number. What is a whole number? We have discussed in the number systems in the very first introduction of real numbers, right? Whole number begins with 0. And and for any whole number n, where a not equal to 0. Initially, we took an example to get an expression in terms of x, which is the square, area of a square, perimeter of a square we calculated. Now we are coming to the definition of a polynomial. What is a polynomial? Polynomial is an expression which is expressed in terms of x as a into x power n, where a being any real number. What are real numbers? The set of all the number systems includes in real number. Alright, and n being any whole number. And a cannot be 0, and n can begin with, when we say whole number, it begins with 0. The definition is quite simple. So whatever the example we have considered, we are trying to put it in decent words. That's what it is, an expression in terms of x which is of the form a into x power n, where a is not equal to 0 and a can be any real number and n can be any whole number. That's about the definition of a polynomial. So far so clear? We are done with the definition of a polynomial. Then let us figure out, now that you know what is a polynomial, now the question arises, what is this? You said it is in power of a into x power n. You say something is in x square and something is of 4x. What is the form of a polynomial? Let's go to the form of a polynomial. The generalized form of a polynomial, general form, is a naught into x power n plus a1 into x power n minus 1 plus a2 x power n minus 2 plus a3 x power n minus 3 plus, and so on it goes, plus an minus 1 x power 1 plus an into x power 0. If you see here, the power of n at the beginning is the maximum power, and it goes on, it is dropping by 1, n minus 1, n minus 2, n minus 3, and to the last two terms it becomes x power 1, and for the last term x power 0, which is nothing but 1. Alright, if I try rewriting the same statement, it becomes a naught x power n plus a1 x power n minus 1 plus a2 x power n minus 2 plus a3 x power n minus 3 plus, and so on, plus an minus 1 into x plus an, since x power 0 is 1. This is a generalized form of polynomial. This is an expression in terms of what we said, a into x power n, right? Here I gave for the a value, I gave in order to distinguish the multiples, a naught, a1, a2, a3 and so on. It goes till an, the last but one term being an minus 1. And for the x powers, it begins with n and it decreases to a value of 0 as we go on. Alright. So this is the general form of a polynomial. How is it? In the form of ax power n, where a's are given like this and the power as we go on in the expression, it decreases. Alright, that is about the general form of a polynomial. Let's get to know, now that we said it is expressed in the terms of n and a naught. So we need to understand, we now understood that polynomial is an expression in x. What is a naught? What is n? We should know them, right? So, madam, just now you said n is any whole number, a is any real number. Yes, we have a names for them as well. What are they? The power, the maximum power of x. The maximum power of x is known as degree of a polynomial. What is it? Degree of a polynomial. Degree of polynomial is nothing but when you are given an expression in terms of x, what is the highest power of x that is seen in the expression is known as degree of polynomial. Is nothing but, in simple words, the highest power of x, the highest power of x in expression. Okay, then what is this a naught, a1, a2, a3 and so on, an minus 1, an? Nothing but the constants which are multiplying the x power terms are known as coefficients. What is the spelling? coefficients. Many of the students confuse between two terms. One is quotient and the other is coefficient. Coefficient is in an expression when we are dealing with polynomials, the constant multipliers that are available next to x terms are known as the coefficients. But quotient is the term which comes when we are doing the division part. We have divisor, quotient, remainder and dividend, right? So quotient is the term. Quotient is in division. Coefficient is in polynomials when we are dealing with expressions in terms of x, the constants that we have a0, a1. In the generalized form, what are the coefficients? a0, a1, a2, a3 and so on, an minus 1, an. These are called coefficients, which are nothing but multiplying the x terms, right? The constant terms which we are using to multiply the x terms in the expression. These are known as coefficients. We understood the definition of polynomial, which is an expression in terms of a into x power n, where a being any real number and n being any whole number. Then we understood the general form of a polynomial. Within the general form, what is the degree of a polynomial and what are the coefficients of polynomial. That is what the concept which we have covered so far. Next thing that is going to come into the picture is nothing but the value of a polynomial. Value of a polynomial. So as the wording it says, this is value of polynomial. What do you mean by polynomial? Value of a polynomial? When I give you a term in terms of x and I say x is equal to 1, that indicates that x is equal to 1. 1 is the value of x, isn't it? The same way, value of a polynomial, say for suppose we have let us assume a polynomial p of x is equal to x square plus 2x plus 1. Alright. Now, if I substitute x is equal to 0, okay, p of 0 is equal to 0 plus 2 into 0 plus 1, which indicates 1. P of 0 is equal to 1 when x is equal to 0. So, the value of polynomial p of x is equal to 1 when x is equal to 0. So, this is nothing but value of a polynomial. What is it? P of 0 is nothing but value of a polynomial when x is equal to 0. So, value of polynomial is nothing but whenever within the expression, polynomial is nothing but an expression in terms of x, right? When you substitute a value in your expression, then you'll get some result. That is nothing but, the result is nothing but the value of a polynomial for the substituted value of x. Alright, so that is about value of polynomial. Next word that you are going to hear very frequently in this chapter is nothing but zeros of polynomial. Alright, let's listen to this concept carefully. On this concept only all the exercise problems are based. So you have to listen to this concept carefully. Do not skip this video for the concept part. Alright, so zeros of a polynomial. What are zeros of polynomial? What do we understood from the term value of a polynomial? Value of a polynomial is nothing but when you substitute some value of x into an expression, the result that you are getting is nothing but the value of a polynomial for the value what we have substituted as in x, isn't it? The zero of a polynomial is nothing but when you have an expression, say for suppose p of x is equal to ax square plus bx plus c. So the zero of a polynomial is expressed as whatever are the values of x for which p of x becomes 0. Listen to this again, I'm going to repeat. So, for whatever the values of x, the expression results in 0 is known as the zero of polynomial. What is zero of polynomial? The value for which the polynomial value becomes 0 is nothing but zeros of polynomial. So let me give you an example so that you have a better understanding of this. So let me consider an example of x square minus 5x plus 6. Is this an expression? Yes. Is it expressed in terms of x? Yes. Is it same as the general form which we have discussed? Yes. So let's try sorting out this one. Even before this, factorization is a concept which we have learnt in our earlier classes, 8th and 9th classes. If you guys are not aware of it, let me tell you in detail. When we do this factorization part, the product of the first term and the last term, the coefficient of x and the last term we consider. What is it? 6 into 1 is nothing but 6. And the sum of the factors should result in this value. Alright. So how do we factorize this? What are the factors of 6, 2 and 3? When I sum them, 2 plus 3 becomes 5 and 2 when multiplied with 3 gives 6. So how am I going to write these factors? This is nothing but x square minus 2x minus 3x plus 6. Now I have split 5 into 2 factors, which is 2x and 3x, and since this is minus, I have given this. Minus 2 multiplied with minus 3 gives me plus 6. Alright, and minus 2 when I sum it up with minus 3 gives me minus 5. So this expression is split into these two expressions. If you guys are not aware of factorization, just let me know in the comment section so that I'll do a separate video on factorization so that you will understand way more better than this. Alright. So in this, from the first two terms, x is a common factor. I am taking it out, x into x minus 2. In these two, I am taking out minus 3 as a common factor, which becomes x into minus 2. So this is x minus 2 into x minus 3. If I equate them to 0, I'll get x as x minus 2 is equal to 0, x minus 3 is equal to 0, x is equal to 2 and x is equal to 3. Now, either 2 or 3 are nothing but zeros of polynomial. Now, the question comes up, how do you say that zeros of polynomial? Said zeros are the ones for which this expression becomes 0. Let's try test it out. For the first thing, let me consider this as p of x. I am substituting a value of 2. 2 square is 4. Minus 5 2s are 10. Plus 6. 4 plus 6 is 10. 10 minus 10 is 0. Alright. Next, I am substituting the value of 3. 3 square is 9. 5 3s are 15. 9 plus 6 is 15 minus 15 is 0. So, 2, 3 are nothing but zeros of p of x. Alright. So, zeros of polynomials are nothing but for the value of x which results p of x is equal to 0. Those are known as zeros of a polynomial. If you substitute that value in the expression, you will get the result as 0. Those are known as zeros of a polynomial. So far, what we have covered, we have given an example first to understand how the polynomial expression looks. Then we went through the definition of a polynomial, which is nothing but it is an expression in terms of a into x power n, where a being any real number and n being any whole number, and a cannot be 0. Then we went to the general form of polynomial, which is in the form of a naught x power n plus a1 x power n minus 1 and so on. It went till a n x power n. While writing the general form, we understood that the power of x comes down as we move on and the coefficients are rising as we move on. And then the last term in the general form is nothing but a n, which is just a constant. It is just a constant. Alright. Next, we understood the degree of the polynomial, which is nothing but the highest power of x. And then we understood the coefficients, which are nothing but a0, a1, a2, a3 and so on, which are given in the generalized form. Then we went through the value of a polynomial. Value of a polynomial is nothing but when you substitute a value in it, whatever the result you are getting is the value that you are getting for when you substitute the value. Okay, p of 0 is equal to 1 when x is equal to 1. The value of p of x is 1 when x is equal to 0. That's what we figured out. Then we understood the zeros of polynomial. What are the zeros of polynomial is nothing but the value of x for which the expression, the polynomial results in the value 0. They are said to be the zeros of polynomial. We have discussed this the same with the help of a example. And we proved that those are zeros of polynomial. That is about the concept that is needed for us to solve the exercise problems. Even before this, once you are done with the concept, just pause this video here and try going through the examples. Later we can jump into the exercise. So I hope you have already gone through the examples. Now whatever the concept we have learned, let's apply it in the exercise problems. So I am ready with already problems listed on the board. So let's get started without any delay. Alright, let's jump into the first problem. Here it is given that in p of x is equal to 5x power 7 minus 6x power 5 plus 7x minus 6. Is it in terms of a0 x power n plus a1 x power n minus 1 plus a2 x power n minus 3 and so on? Yes, it is. See, the powers of x are coming down as we go on. The last but one term is x and the last term is constant. So, this is a polynomial. And now, coefficient of x power 5. What do we said? Coefficients are nothing but the constants that are available next to x. When we are looking at an expression. Here, they are asking us the coefficient of x power 5, which is nothing but 6 or minus 6. Now, many of the students get confused here, either 6 or minus 6. But if you look at the general form of a polynomial, we have said that it is in the form of a0 x power n and so on there. There, we do not have any minus signs. We just have all the plus symbols. So, here, this is minus 6. So, this minus is corresponding to the coefficient itself, not to the expression. We have to understand that because the expression is like this, right? a0 x power n plus a1 x power n minus 1, a2 x power n minus 2. You don't see any negative signs, isn't it? So, if you have any minus, that is nothing but that is always corresponding to the coefficients itself. Alright, what is the coefficient of x power 5? This is x power 5. What is the coefficient? The constant that is multiplying x power 5, which is nothing but minus 6. Alright, next, degree of p of x. What is degree? The highest power of x in the expression. What is the expression? 5 into x power 7. 7 is the degree of this expression. Next, what is the constant term? As I said, as we go on, the last but one term is x power 1 and the last term is x power 0, which is nothing but 1, and that term is treated as a constant, that is nothing but minus 6 again. Why is it minus 6? Why not plus 6? Because these negative signs are not in the general form of a polynomial. Whatever the signs that are corresponding, if it is plus, then it is okay. If it is minus, then that belongs to the corresponding either coefficient or the constant. Alright, that is about first problem. Let's jump into the second problem. In the second problem, they are asking us to figure out whether the following statements are true or false. Alright, first question. The degree of a polynomial root 2x square minus 3x plus 1 is root 2. What is the degree of a polynomial? It is nothing but the highest power of x. That is nothing but 2. But he is saying root 2. Is it true? No. The answer is false. Next, the coefficient of x square in polynomial p of x is equal to 3x cube minus 4x square plus 5x plus 7 is 2. Forget about what he has given. What is the coefficient of x square? Is nothing but minus 4, isn't it? Then what is given? 2. So the answer is again false. I'm boxing them to give a better look for you guys to understand. All right, the degree of a constant term is 0. What we have got to know, a n into x power 0. What is the degree of x here? 0. Only then x power 0 is 1, hence a n is a constant is what we have assumed while understanding the concept, isn't it? So the degree of a constant term is always 0. Answer is true. Next, 1 by x square minus 5x plus 6 is quadratic polynomial. Is it a quadratic polynomial? First thing, in order to be a polynomial, it should be in sync with, it should be in the form of the generalized form, which is a x power n plus b a1 x power n minus 1. Is it in that form? No, it is 1 by a into x power n form. First of all, this is not at all a polynomial. How come it becomes a quadratic polynomial or a linear polynomial? Let's look at it later. So first of all, this is false. This is not a polynomial. The answer is false. Next, the degree of polynomial, the last bit, the degree of polynomial is 1 more than the number of terms in it. Degree of a polynomial and number of terms. When we are learning the concept, the degree is nothing but the highest power of x. That is what we have learned. Now he is telling us this is in relation with number of terms in it. Did we find any relation with that? No. Nowhere the degree is related to the number of terms in the polynomial. Hence this statement is also false. This is false. True or false, you guys can do. I can leave that for you. But in order to justify and give reasons, that's the reason I am explaining this second problem to you guys. Alright, we have given the reasons for this as well. If you want to make a note of it, please do make a note of it. Next, let's jump into the third problem. If p of t is equal to t cube minus 1, then find p of 1 minus 1, 0, p of 2, p of minus 2. Alright, what is the given? P of t is nothing but given p of t is t cube minus 1. So let us substitute 1 first. P of 1 is equal to 1 cube minus 1. 1 minus 1 is 0. P of minus 1 is equal to minus 1 whole cube minus 1. That is nothing but minus 1 which is equal to minus 2. When you multiply minus 3 times, it becomes minus into minus plus, and plus into minus is again minus. So this becomes minus 1. Alright. Then P of 0 is equal to 0 cube minus 1, which results in minus 1. P of 2 is nothing but 2 cube minus 1. 8 minus 1 is 7. P of minus 2 is nothing but minus 2 whole cube minus 1. So when you are substituting negative numbers, remember that the cube or the square, whatever the power of x, that also applies to the symbol. I mean the positive symbol or negative symbol. The degree applies to that symbol as well. Alright, this becomes minus 8 minus 1, which is nothing but minus 9. Alright. That is about problem number 3, wherein we have figured out these are nothing but the values of polynomials when t is equal to 1, minus 1, 0, 2, minus 2. This is the same place where we have learned the value of polynomial definition, right? The same place we are writing the problem as well, solving the problem as well. Next, let's jump into the fourth problem, wherein they are asking us to figure out whether minus 2 and 2 are zeros of polynomial x power 4 minus 16. When do we call the values as zeros of a polynomial? When we substitute those values and we get the result as zeros. Then we call them as zeros of polynomial. So let p of x is equal to x power 4 minus 16. Alright. Now p of minus 2, I am substituting in order to check whether they are zeros or not. I am substituting minus 2. Minus 2 to the whole power of 4 minus 16 is nothing but 16 minus 16, which results in 0. Okay, then P of 2 is nothing but 2 power 4 minus 16. 16 minus 16 is again 0. So when we substitute minus 2 comma 2 in P of x, P of x value is 0. P of x is equal to 0. Hence, minus 2 comma 2 and 2 are zeros of polynomial. Zeros of polynomial. So, alright. And when it comes to the fifth problem, it is nothing but exactly the replica of fourth problem. It can be solved in the same way, just what we did for the fourth problem. So I'm leaving it to you guys to explore on your own. If you're not able to solve it, just let me know in the comment section so that I'll be solving it for you guys. So this is about the first video, Polynomials part 1, wherein we have learned the initial concept, introduction to it. What is a polynomial, degree of a polynomial, coefficients, value of polynomial, zeros of polynomial. 5 concepts we have learned, and the corresponding exercises also we have solved. If you are familiar with the concept, see how easy to solve the exercise problems. That's the reason I request you guys to not to skip the concept part and directly jump into the problems. You should learn the concept. Alright. So do not skip the videos when the concept is being explained and go through it. Alright. So that's about this video. This is Polynomials part 1. Later in the second video, we will get to know the concept that is needed for 3.2 and try to solve the 3.2 problems as well. As I keep on saying in all my videos, examples are heart of maths. So please go through the examples even before jumping into the exercises. If the exercise part is coming up, just pause this video here and start looking at the examples and then go through the exercise. So that is about this. And if you like the content, please share it with your 10th classmates or any 10th class students in your circle. And please do subscribe to Anantha Lakshmi Academy. If you like the content, do like, share and subscribe. If you subscribe to Anantha Lakshmi Academy, then you get to know whenever I upload a video of the 10th class mathematics chapters. So that's all. Thank you for watching.